Hey, everybody. This is good. As you filter in, I'm going to start my talk a little strange and read to you from the namesake of this talk, which is Stephen Hawking's A Brief History of Time. So this is from Chapter 1, Our Picture of the Universe. A well-known scientist, some say it was Bertrand Russell, once gave a public lecture on astronomy. He described how the Earth orbits around the sun and how the sun, in turn, orbits around the center of a vast collection of stars called our galaxy. At the end of the lecture, a little old lady at the back of the room got up and said, "What you have told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise." The scientist gave a superior smile before replying, "Well, what is the tortoise standing on?" said the scientist. "You're very clever, young man, very clever," said the old lady. "But it's turtles all the way down." Now, you might be wondering, of course, the idea that our universe is some sort of plate and there's turtles floating in space. You might think that's like a pretty odd idea, but this talk is going to be the kind of talk that's going to ask you to look at some of the concepts that you might take for granted and ask you why you think they're true. Now, what on earth would something like that, with turtles in space, have to do with JavaScript? And hopefully, by the end of this talk, you'll have figured it out. All right, so hi, my name is Ashley Williams, as was introduced. You might know me from Twitter as AGDubs, and if you do, I am very sorry. Do not follow me, I'm terrible. I work at this tiny company called NPM. Has anyone heard of NPM? Yeah, cool. So yeah, that's where I work as a services engineer. Shout out to the fact that we released NPM 5, download it, it's very cool. This talk is not about that, but if you want to talk about that later, find me. So if you're the type of person who watches slides, sees a typo, and cannot handle themselves, please submit a PR. This is a Git repo. I'm totally happy for them. So I always like to start my talks by saying that I like to think about thinking, particularly the type of thinking that happens when people write code. And the point of this talk today is to maybe get you to also think a little bit, at least about the type of thinking you do when you write code. So to get that thinking started, I'm going to pose you with this. I'm not going to give you my answer quite yet, but this is a PR that came into a repo for a documentation project for a programming language, and they're attempting to remove the jQuery dependency by adding 400 lines and removing 200. And so this talk is going to be questioning the ideas that we think about when we're thinking about dependency and modularity. How many people think this is a really obvious thing to choose, accept it or not? All right, good. All right, this talk's for you. All right, so I'm one of these people who has for a very long time been a teacher as well as an engineer, and I like to say that teaching is nature's way of letting you know how sloppy your thinking is. And over a long period of time of teaching people Node across the world, some people in the audience are in these photos, we run into some fascinating questions from beginners. Now, here's one of the most fascinating ones, and this is actually one that a student of Steve Kinney's asked him, which was, how did you get permission to publish a module on NPM? True question. Many beginners think that you actually have to somehow get permission, that there's an exceptionalism to being able to publish a package. But as I think, hopefully you know, that's simply not the case. Literally anyone can publish a package to NPM. Now, once you get past the idea of who can publish, the next question really is, how do you decide what goes inside a module? And so, like a proper scientist and wanting to get the correct answer, I went to Twitter, as I always do, and I was like, hey, what is your primary motivation for writing or using modular code? Now, I got a huge number of responses. This is a topic that a lot of people like. But it was interesting because the responses were very diverse. So one of the first sets of responses I got was that people believed that being able to write modular code made them more disciplined, made debugging the code easier, made it easier to test or document. Alternatively, some people wrote that they made their code modular for reuse so that they could do something in the future in case their code changed. I put Bradley on his own slide because in a talk about modularity, you got to give Bradley a shout out for all of the work he's done implementing ES6 modules. So if you like ES6 modules, particularly you like them in Node, you should thank him. All right, so then of course it was Twitter, so there were some shit posts. They might have been from some of the conference organizers that you know. We'll let those be. But so the biggest theme that we got was this idea of being able to reuse things, and in particular reuse things by separating concerns. Now lots of people love this term, separation of concerns, to the point that people said it almost exactly in their responses. But I thought that it was awful vague to be something so specific that everybody was saying. So I tried to push the question a bit further, and I said, okay, separation of concerns. How do you decide what the concerns are? And this really stumped people. People went from having tons of verbose answers to going, intuition mostly? Said this person. This person suggested throwing darts, which is about as scientific as you can get, I guess. Now, even one of my JavaScript heroes, Marijn Haverbeek, who is here, I think, as an expert, he wrote the book I learned JavaScript from, even he responded, and he was like, I kind of have an answer, but you know what? There's a lot of practical, accidental, even aesthetic considerations to this question of how you separate out your code. And here's the punchline. The absolute best answer about why did you split up your code was people got mad when I put it all in one file. So you might remember this from the intro that I was not here for, but saw on Twitter. I guess there was a lot of people got mad. But believe it or not, people do get mad in programming quite a bit, and I could definitely see how if someone put their application all in one file, there'd be a bunch of people grumping about it. So by looking at the summary of these things, in general, I thought it was very interesting because in the end, people really had no idea how or why to module. They had some kind of inclinations, some intuitions, but when you drilled down pretty hard, they didn't really have an answer. However, overwhelmingly, everybody thought that it was good. No one responded with, don't modularize your code. So we're in this interesting position where there's a lot of people who feel very strongly about something, but don't really have a solid grasp of why. And so this kind of made me think, all right, we have this huge batch of stuff, and maybe individually they all make sense, but we don't have a coherent picture of the world. A bit like this store, which is a real store outside of Madison Square Garden in New York City. I don't know if it capitalizes on all that it promises, but I would only assume it does. So this made me think, and I did something that's a very classic Ashley thing that a lot of people otherwise who don't know me might not think a normal person would do, is that I was like, oh, the way people think about modularity is the way people think about time. Everybody has this really intuitionistic idea, like time passes, but nobody has any friggin' idea of how time works. If you do think you have an idea, you should find me at the party, because I'm very interested. But yeah, so this made me think, okay, I love this book, A Brief History of Time, because what it does is it goes through and it kind of chronicles the intellectual history of how we've been thinking about describing our universe. So my goal today is not necessarily to give you any answers, but I do want to talk about the ways that we think about modularity, and then potentially give us some pointers to get in the right direction when we think about splitting our code. Because fundamentally, splitting our code is so important and so critical to our daily lives that it's pretty unsettling that we haven't really examined it as closely as I think we should. All right, so I feel like I'm in a pretty good space to talk about this because the package ecosystem, I personally think, is JavaScript's picture of the universe. And working at NPM, I'm pretty close to that ecosystem. So NPM, I've checked this probably a week ago. We have 472,000 packages, which puts us about a third, and 3 times as much as the next package ecosystem. So packages and modularity mean a lot to JavaScript because NPM is the largest module repository in the world. Potentially the universe. I don't know if aliens have package managers, but I feel like we'd be in the running. All right? But what I want to do is ask, okay, why is this the case, right? Why are we modularize all the things, cut my code into pieces. This is my JavaScript. Sorry, I had to do a pizza joke. I just had to. It's late. Got to get you guys going. Anyways, no, now let's get really serious. This is a proper computer science talk. So let's quote Dijkstra, right? Let's do that. All right, so Dijkstra says that the programmer is in the unique position. They have to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. The automatic computer, lol, the automatic computer, okay, the automatic computer confronts us with a radical new intellectual challenge that has no precedent in our history. All right, so I'm not like the biggest fan of computer science exceptionalism, but I definitely think that he's onto something here. All right, modularity is the way we as programmers address this challenge that we need to be thinking in very, very, very deep conceptual hierarchies. All right, so we know kind of the problem that modularity is solving, but what is modularity? So again, to the good sources, let's do a little Wikipedia. Modular programming is a software design technique that emphasizes separating the functionality of a program into independent, interchangeable modules, such that each contains everything necessary to execute only one aspect of the desired functionality. So you may or may not be getting the idea, but I'm a little worried about this one aspect part of it, and that seems to be the clincher of that definition. All right, so in JavaScript, we have this idea called the small modules philosophy. How many people here have heard of that? How many people like it? Interesting. All right, so one of the fiercest fighters for the small modules philosophy, and he does it with his actions because he's probably one of the most prolific publishers on NPM, is Cindersaurus, and he says, it's all about containing complexity. By making small, focused modules, you can easily build large, complex systems without having to know every single detail of how everything works. Our short-term memory is finite. So this doesn't get us terribly closer to where we should separate things, but it's certainly suggesting that we have a biological constraint that's going to require us to make small packages so that we're able to actually understand the thing that we're working on. All right? And so this obviously begs the question, how small is too small? Now, this is a classic critique of packages in NPM. People love getting upset about this. The one-line node modules problem. People do not like these. However, they are installed constantly, continue to be published, and are some of the absolute most popular packages on NPM. So you have to ask yourself, for all this critique, why is it that we continue to use them? Now, I can't talk about these one-line node modules without talking about left pad. Warning, if you make jokes about left pad to me, I'm going to get real pissed, so don't do that. All right? That being said, I think that left pad is really interesting to talk about because it brings up this idea of at which point are we leveraging this tool of modularity too much, right? Because somebody unpublished this tiny, tiny little package and the internet went berserk, all right? And this is only 11 lines of code right here. Is it worth it to have a way of abstracting this code out? Is this doing us any good? So the thing actually that I think left pad was most fascinating for me was that people started getting really aggressive, and they suggested that even the existence of a left pad module meant that we had like somehow forgotten how to program. That using this at all meant that we were terrible programmers. And so I kind of need a minute here. All right, this makes me think of this talk, which if you've seen it or seen me online, you know I'm not a fan of, which is this idea that there's some sort of real programmer out there, and that if you use any sorts of tools, be it a build process, a framework, or yeah, even a package that contains 11 lines of code, you're not a real web developer. And I just have to say, nuh-uh, that's not cool, all right? Building small reusable abstractions is the foundation of literally all computer science. So did we forget to program when we stopped writing C, stopped writing assembly, stopped doing electrical engineering, which I can only say vaguely because I have no idea even what that would be called. I assume it has to do with soldering, I don't know. But yeah, this idea that there's no true programmer because you use tools, all right, it's the no true Scotsman fallacy, but I don't even need to go into that. So if you're upset about tiny little modules because you think it means you're not a programmer, I'm having none of that. Okay. So moving on, what I do want to say is I think that actually making tiny little modules is a great idea. And this is because what I envision as the best type of application. So Substack, who is also a prolific author on NPM, describes his best application this way. He says, when applications are done well, they are just the really application-specific brackish residue. This is such good terms here, that can't be so easily abstracted away. All the nice reusable components sublimate away onto GitHub and NPM, where everybody can collaborate in the commons. And if you know me, I'm a fan of the commons, a lot. I'm a big fan of the commons. But commons are hard, and even though commons are hard, I think the JavaScript ecosystem proves that we can do the commons right. This is the graph of our weekly downloads. At this point, NPM is averaging 2 billion downloads a week, which means that something about breaking things into tiny packages is working well. All right? So this doesn't necessarily mean that it's without problems. So this is an Alex Norris comment. And so you can just read there, instead of I want things to be different, I want things to be modular. Oh no. All right. So this is when it comes to this fantastic book by John Gall called Systemantics, which is about how systems work, but also especially how they fail. And so he says a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a simple system. And right now in the JavaScript ecosystem, we have a complex system. And this complex system has been causing us problems. And so from now on, I'm going to talk a little bit about the problems in modularity. So Nolan Lawson wrote, "The more I modularize my code, the bigger it gets. Over 400 milliseconds is being spent simply walking my browserify tree." And so he wrote this interesting article called "The Cost of Small Modules." And the subtitle was, "Why One Horse-Sized JavaScript Duck is Faster Than 100 Duck-Sized JavaScript Horses." I saw this, I had to illustrate it. I was like, come on, this is perfect. But the interesting thing that he says in this is he goes into a typical web application has a ton of little modules. And the reason it has a ton of little modules is because this really improves developer experience. All right? There's lots of these tools that we take to take those little individual modules and prepare them for when we're going to push our code into production. Now, these tools are extremely important because modularizing our code helps us as developers, but it doesn't come without a cost. All right? So one of the things that he notes in this article is the fact that even just splitting our code up into closures, into different functions, is actually costing us a lot of stuff, a lot of time at runtime. So looking at stuff like Webpack and Browserify, just plain, and then comparing something like rollup and closure, which moves all the code up into a single closure, actually, if you take a look at these graphs, has a significant amount of runtime improvement. There's very little of that orange runtime when you're maintaining the modularity in your runtime code versus when you're using something that's going to actually take that modularity and collapse it. So what is the takeaway from this? Oh, also, by the way, these tools, there's tons of new ones. There's a new one that came out just a few days ago. It's pretty neat, and it's doing the same thing, where it's collapsing this ability for us to modularize our code and putting it all into one single thing. Because preserving that modularity actually ends up hurting our end users. So I told them that they have to stop publishing new tools because I'll never finish this talk. And I'll also never finish on time. But the goal here is to say that the use of modularity has kind of grown to such a scale that web developers are being confronted with ideas that we've never anticipated. Oftentimes when we think about performance in web development, we think about network latency. Obviously, we're like, how long is it going to take over the network? But it actually turns out that with the number of modules that we are using across all of the devices that we have, particularly low-power devices, low-level programming concepts are now more relevant to web developers than ever. And we're a little bit not prepared to understand this. And so I like to say, I, for one, welcome our new compiler, transpiler overlords, because we need a way to mitigate the stuff that we do to improve our developer experience and not have that cost end up on our end users. So Rich Harris, I think, says this really great. He says, yes, small modules are easy to write. They're easier to test. Yeah, it's easier to adhere to Semver. These are all things that make your life as a library author easier. As we've seen, they come at a cost for others. So the small modules philosophy totally benefits the library writers, but it disadvantages application writers because they have to deal with all of those tiny pieces when they're putting something together. And fundamentally, because that's extremely difficult, it turns out that modularity actually harms end users by costing them time. So how did we end up here? All right, and I love to quote Thomas Kuhn here, who says, "Scientists work from models acquired through education and through subsequent exposure to literature without knowing or needing to know the characteristics that have given these models the status of community paradigms." What I'm saying is that it's been a little inconvenient for us to interrogate why we love modularity so much. We just see it happening, the tools make it easy, and so we use it. So this is the CTO of NPM SiegeBot, and I think one of the neatest things she says, she's talking about microservices here, but she says your monolith is complex, your application is complex, but to split it up, to modularize it, actually makes it more complex. And so we're kind of in a pickle here. I'm saying modularity makes our lives as developers easier, but somehow this is also making them harder. This is some graffiti that I saw in San Francisco. My solution is probably worse than the problem. So now we're in another oh no situation. So this is one of my favorite computer scientists, Rich Hickey, and he says most of the big problems of software are problems of misconception. So again, I want us to be focusing on the concepts that drive our day-to-day work. All right? And so what I like to say is when we think about programming, right, software development is change management. Fundamentally, this is why we use version control, this is why we have Semver. The hardest part of programming is the fact that it changes, all right? And this is very interesting because this actually features very heavily in A Brief History of Time by Stephen Hawking. In fact, he says, it is an interesting reflection on the general climate of thought before the 20th century that no one had suggested that the universe was expanding or contracting. Which is to say, when we tried to paint a picture of the universe, they never thought that the universe would have changed. They just assumed it was exactly as it was. And I think oftentimes when we think about breaking up our code, we evaluate it in that same static way. So it turns out that I was like, I did ask Twitter, how do you modularize? But I also went on Google Scholar and I was like, how to module? And there's actually an amazing paper on exactly this topic by an author named David Parnas, and this is perfect. The paper is called On the Criteria to be Used in Decomposing Systems into Modules. And it turns out that he has an answer that nobody provided when I asked on Twitter. This is what he said. He said, start with a list of difficult design decisions, or design decisions that are likely to change. Each module is then designed to hide such a decision from the others. So here's the trick. The goal of modularity, we always talk about it being making our lives easier. But the truth of the matter is that we should be using modularity to hide the things that are hard. So at this point, you might be worrying, oh gosh, like, I had a lot of conceptions about modularity that were not correct. How do I even go about computering? And Rich Hickey comforts us. He says, none of us are born knowing how to write software. And Cinder even says, you know, as someone who writes a lot of modules, I still don't really know how to do it. I'm still trying to figure it out. And so you might be feeling a little bit of despair. And so this is a famous existentialist philosopher, JeanPaul Sartre. And my friend Tef quotes his book, On C, Programming in C. Every line of code is written without reason, maintained out of weakness, and deleted by chance. I need some water. Anyways. But based on this level of despair, what Tef suggests that we do is he suggests that not only do we write code to help our programs change, but we should not be focusing on code that's easy to extend, but rather code that is easy to delete. He says write code that is easy to delete, not easy to extend. Instead of building reusable software, we should try to build disposable software. I don't need to tell you that deleting code is more fun than writing it. And if you love to do it, you should do it every day. So we come back to this question of, do we delete this jQuery dependency? And so what I thought was very interesting about this is, first, I don't think there's a right answer. There's a lot of good questions to ask about this. But in the end, yes, accepting the PR to remove the jQuery dependency was what people thought. And more than it saying something about people's feelings about jQuery, what I do think it indicated was that we're kind of seeing a return of conservatism in the way we think about using modules and packages in our programming. For a long time, we were using modules totally uncritically. We were doing a lot of work, including lots of them, and we're seeing a lot of people go the opposite direction now, and there's a lot more of this not invented here, I'm going to bundle in my code, and not use a package. All right? But what I want to say is I think there's a really amazing challenge here, and that instead of just rejecting the idea of using tons of modularity, we should be looking for new solutions. Modularity is an old problem that we're dealing with, but at a brand new scale that I think is really exciting. So I had asked recently, a few months after the first time, why do you choose to split your code? And so one of my coworkers, Chris Dickinson, actually I think had a really awesome answer. He said, I have two answers. The first one is kind of like what I would say like academically, but the other one is actually how I think I really feel. And what he says is, programming is like a maze that humans lack the language to describe completely. With practice, you start to internalize the maze. And so that could seem pretty bad. And what I want to say is, internalizing it and using intuition isn't super terrible. It turns out that dogs know calculus, which is pretty neat. You can read this paper about a guy and his corgis fetching a ball. This is true. They are able to actually calculate the most efficient route, which is pretty neat. So they're made of star stuff. And so we can also use intuition to be able to figure out how to do modularity. So we can all be a bunch of corgis, modularize the corgis. But so in summary, modularize your code to make your life easier for sure. But when you're making your life easier, realize that the way you should be separating it out is by isolating the things that are hard. That's how you're going to make your life easier. And then additionally, modularity is not free. In fact, it's pretty expensive. And what works for you as a developer can have consequences for other developers as well as your end users. So the tools that currently exist help mitigate a cost that you're already enduring. Too many people are like, I don't know what all that fancy stuff is. I don't need that. No, they're solving problems that you already have. So you should be looking into these tools and using them. And finally, this is a fast-moving space right now, and there's not a lot of definitive answers. And I can't help but know that on Twitter recently, there's been a lot of really nasty conversations about this. So I want to say quit being jerks to each other on Twitter, all right? All right, so this problem is far from being solved, and I think that getting a lot more people into this conversation and critically interrogating what we think about modularity is super important. So I'll end you with this. This is from Julia Evans, who is the person who everyone got mad at when she put it in one file. She says, the more programming I do, the more things I run into where I don't know, Google doesn't know, my colleagues don't know, but we gotta do it anyway. And when this happens, she says, right, this is why they pay a human with a brain who can investigate and learn. And these should be the problems we're most excited to solve. Thank you so much. This is all of the sources from the talk. Install npm 5.